Hello, we're going to talk a little bit about Bayes' theorem. And Bayes' theorem is a theorem about conditional probability. And if we have two events, A and B, Bayes' theorem says the probability that event A occurs given event B has already occurred is going to be the probability that A occurs times the probability that B occurs given A has occurred, divided by, and now we have kind of a longer denominator, probability of A times the probability of B given A has occurred, plus the probability of the opposite of A times the probability of B given the opposite or the complement of A has occurred. And so when we compute Bayes' theorem, when we compute this, what we want to know is this is what we want to know. We want to know what is the probability of A given B occurs. But we have to have a certain number of known values in the problem. The known values we need are the probability that A occurs, and if we know that, then we can know the probability that the complement of A occurs. Remember, that's just going to be 1 minus the probability that A occurs. We need to know the probability that B occurs given A happens. And we also need to know the probability that B occurs given A complement happens. Right, this one might be a little tricky. I've seen in some problems what they've given us instead of giving us this, they've actually given something like the probability that B doesn't happen given A doesn't happen. And what we want to do with this is to figure out the value we want to know, the probability that B occurs given that A doesn't occur, we just do 1 minus the probability B complement given A complement. All right, so in fact we can find all of these values. So let's look at the example that we're talking about. What if instead of having an event A and its complement, not A, we had multiple outcomes? Right? What if we had A1 could happen? What if we had A2 or A3? What if these were 3 events that could each happen? And I wanted to know the probability that A1 occurred given some other event B happened. Right? If we try and use the original Bayes' theorem, we're going to be a little bit off. So what we can do is just have an extension. And that extension applies to the bottom. So the top will stay mostly the same. And now what we do is we're going to, instead of having 2 brackets we add to each other, like this, we'll have a third. Well, if the probability A1 occurs times the probability that B occurs given A1, the probability A2 happens times the probability that B occurs given A2, plus the probability that A3 occurs times the probability that B occurs given A3 happens. And this is what we use for the problem number 10 on homework lesson 3 problem on homework set 1. And this is what we use to solve that problem. So let's work on lesson 3, homework 1, problem number 10. Right? In a class, we have 3 versions of an exam. We have version A, we have version B, and we have version C. We're told that version A is given to half the class, version B is given to a quarter, and version C is given to a quarter. And right now what we can say is the probability that any student gets A is going to be 0.5. The probability that any student gets version B is going to be 0.25. And the probability that any student gets version C is going to be 0.25. Sorry. All right. We're also told that the pass rate for A is 71%. The pass rate for B is 64%, and the pass rate for C is a whopping 95%. And what this tells us is a pass rate we can think of as the probability a student passes given they have test A. That we turn into a decimal, and 71% will be 0.71. The pass rate for B, we can say the probability a student passes given they have test B. That's going to be 0.64. And the probability a student passes given they have test C, 0.95. And what the question asks us is, what's the probability that if they pass, they received A? What that means is we want to find the probability they received test A given they've passed the test. And again, this fits exactly that Bayes' theorem extension. So I want to know the probability they got test A given they passed the test. And now we can fill in that Bayes' theorem. So that means I want the probability they received test A times the probability they pass, given they have A, divide it by, and now we have that three-part denominator. Right? This is going to be the probability of A times the probability of a pass, given they have test A, the probability they get test B, times the probability they pass, given they got test B, times the probability they get test C, times the probability they pass, given they received test C. And we can fill all of this in, right? Let's see. 0.5 times 0.71 divided by 0.5, 0.71 plus 0.25 times 0.64 plus 0.25 times 0.95. Right, we can compute each of those. 0.355 0.16 and we really kind of want to hold off on rounding until we have to. And so we can compute this, and let's see, if we do this correctly, we will get 0.471761. And it wants us to round it to that many decimal places. So that's the probability a student will pass. That's the probability that given a student has passed, they've received test A. That's just a quick example of Bayes' theorem. If you have any other questions, feel free to shoot me an email. All right, thanks. Bye.